Well, good morning, everybody. I think a lot of you already know me, but for those who don't, I'm Bruce Richardson. I work in Intel in Shannon, in DPDK.org. I'm also the maintainer of the Next tree for the last couple of releases. And I'm actually not here to talk right now. I've actually got a talk tomorrow, but I'm here today just to try and moderate and hold an open discussion about the DPDK roadmap, and basically where do we see DPDK as going, what do we want from DPDK, what do we think we need from DPDK, how can we make it better. There has been published from Intel, Tim O'Driscoll sent up an email about every 3 months saying some of the things that we at Intel are looking to upstream to DPDK with each release. But I'm not going to try and talk through that. If some of it comes up in passing, that's great. But I want it to be more an open discussion and talking about not what we're saying is there already or what we're saying we're doing immediately, but more aspirational. What do we think we need? Where are the big gaps? Where are the rocks that we need to move to help make DPDK more useful? Because if it's not useful and usable, then there's not much point in it. So, to sort of get us thinking, I've put together a couple of slides with some bullet points of things we could possibly talk about, and I'll run through those quickly, and I'm going to take them away so that we don't just talk about those, but then there's a couple of floating mics around. If people can just put up their hands and start coming up with suggestions and ideas and give their feedback on using DPDK and partaking in the DPDK community so we see where we're going. So, first up, some of the things we could look at. What are we missing from DPDK? What kind of drivers? Okay, we've got a fairly good selection of networking drivers. We missing some key ones. Crypto drivers. Do we need other device types in DPDK? There's been some discussion about event dev as a new driver type coming in, which is quite exciting. Things like the scope of DPDK, moving up the stack. We've been quite focused on the L2 level, but then we've got little bits of libraries that are maybe starting to do L3 lookups. We've got our hash library. Do we need to think a bit about the scope of DPDK, or is it okay as it is? What are the common packet processing tasks that people are always trying to do in their applications, and there's not already a library in DPDK that we think there should be? What might those be? What do we remove, if anything? Is there stuff in DPDK that maybe needs to be deprecated, taken out? Other open questions. How do we work with the kernel and with the kernel stacks and kernel user space operating side by side? Have we got large gaps there? I know that we probably have some item on the agenda talking a little bit about KNI, but looking beyond that, are there ways in which we can interact better with the kernel or gaps we have? What about multiprocessor support? Now, as developers, it can cause us major headaches sometimes when developing features, I know that. But I also know that it can be useful, and it's quite widely used. What about the whole issue of driver-specific APIs? This is one that come up. How do we make sure we can get the best performance out of each device that is supported by DPDK? We've come up with the solution for now of having driver-specific APIs that allow us to use that one particular feature, that one particular NIC, and get the best out of it. Is there a better way? Are there problems with this approach? Okay, what about the idea of performance above all else? It's always been the mantra till now of DPDK, and I think it's worked quite well. But occasionally you come across little discussions where you say, well, okay, we take our vector POMO driver, it's missing that offload feature X that's so incredibly common that just about everybody uses it, but it knocks 2% off our performance, okay? Well, what if it's 5% off the performance? How do you work that trade-off? That's another thing we could think about. Then lastly, feedback from people who've actually written apps. I'm a DPDK developer, that's my day job. I write code for DPDK, I review patches as much time as I can spend on it anyway, which is sometimes not as much as I'd like. But for those of you who are actually consumers of DPDK, have you got any big feedback for us DPDK developers on writing apps using DPDK? How can we make the DPDK more consumable? The build process is a bit esoteric. Have we got any immediate next steps for how we might improve that? How about working with pre-built binaries? With the packages you get from Red Hat or Ubuntu for DPDK instead of compiling from source, like many of our developers do. You know, there are big changes we can make there, or there are small changes we can make there, or even better, small changes we can make quickly to help make the app developer's life easier. And then any other feedback about integrating with other apps, maybe pre-built legacy code. You know, one that has come up on the main list is, you know, the whole thing of how do you get logs in and out of an already existing logging system? How does DPDK logs interact with that? So that's basically it. Those are some of the things that I've come up with for things that maybe we need to see on a DPDK roadmap. And the other thing is, if you're got something that you're thinking you could contribute to DPDK over the next couple of releases, by all means, feel free to talk about that as well. So there's 2 roving mics, so just for the sake of making sure everybody can hear what's being said, if people can put up their hands. I do want to try and make this an open discussion. If you don't, I'll have to do something like start telling jokes or that. You do not want to be here for that. So anybody want to kick it off? Anybody got any big rocks, or what do you see? Let's start off. What do you see as the biggest problem with DPDK? Okay, there's a hand up down there. Let's get you a mic. Maybe one that's turned on.
No. Hello? Thank you. So Bruce, what about protections of some kind of DPDK application? I hear that many times from consumers. They want to have some kind of DPDK applications. What can DPI, stacks, or even regular applications? But as you know, when we run on top of an operating system, each process has its own protection domain. But here on DPDK, whatever thread can crash the whole system, or let's say the whole DPDK application.
Yep. No problem.
I don't know if I'm the only one to have this problem, but I hear that from time to time at least.
Anybody else seeing that as a big problem, or anybody offering any solutions? It's not one, to be honest, I've thought a lot about. You know, so what Sven was saying was, you know, the protection of a DPDK process. Do I need to stand back up here so I'm not in front of the speaker? So that if one thread has a problem and crashes, it doesn't bring down the whole application. Okay. Anybody got any thoughts on that? I suppose that's one of the things tying into the multi-process model that could help, but it has its own problems as well. Has anybody got applications that work around that? Yeah.
If you have that, you will need fast messaging between processes. So it's a different problem. And another problem is that the memory is in pool of fixed size. So even in Cisco in the 80s, we had something better than that. So a pool that with variable size, you can do a malloc and get a pool for TLD. So these are the 2 problems to solve the first problem.
Okay. And can I just ask, have you got a solution for that, that you're using in your own products, or any tips that from your past experience that you could share for DPDK?
Yeah, we have a solution for that in Cisco routers, but for now we just use more memory because it's cheaper than implementing that. But it would be nice if someone could do that. The algorithm is known, right? It's from Linux slab.
Okay. So they've got 2 hands going up over here.
Yeah, so in our, I mean, we also had this problem, like the memory protection. The DPDK maps everything into the virtual address space. And I guess we talked about earlier that we have this selective mapping, which we never upstream, unfortunately. We were never allowed to do that, but like improving the memory management, where you can just work with domains. Like in our case, we have our private, per-process private memories, and so it doesn't. You don't have to map the whole memory into every processes area. So I think there's a lot to do in the multiprocessing area. Like one is the this protection, memory protection, and at the same time. So what you can also do is like you can map, like if you have the control plane code, which is mapping a particular virtual address space into the process, and in another process you can map that as a read-only memory. So like it would be quite simple, I guess, to extend the existing memory APIs to do this kind of mapping. Like a mem zone could be particular mem zone could be mapped into the virtual address space, and then when a process attaches to that mem zone, that's where it gets mapped into the address space, and you can map it as read-only, read-write, depending on the flags you're passing. So basically, that's just.
Okay. Anybody else got any feedback on that? Keith?
Not necessarily on the multiprocessor. That one's a difficult one to solve because there's a lot of problems with locking. If you do have a lock and various resources that are shared. But the other one I wanted to talk about was the make file that you brought up there. Yeah. How we do the builds. And as much as I actually do really like our build system, once I get used to it, it's pretty good. But I'm starting to look at different areas for how to make it a little more common, meaning that it isn't something very specific to us. And I was looking at CMake. That seemed reasonable, but I don't know if there's anything else out there that would make it easier for us to build our system on. I mean, I'm not a big proponent of auto tools. I think they're horrible. But is there anything else that we can do to make that more mainstream, I guess?
Yeah, I'm sure there must be plenty of people with opinions on the build system. Folks who are building applications, how do you manage with integrating your app with a DPK with its own esoteric, as you said, build system? Or what way do you think we can improve that? Roger?
I'm not sure I know how to improve it, but I can tell you that integrating it into an existing system can be difficult. In our case, we essentially created a parallel environment because our build environment is so different. I don't know if there are ways to make it easier for someone who has their own existing system to integrate DPDK into it, because it so much depends on what that existing system is, right?
Right. So can I just ask then, do you compile up DPDK separately and then take it, that's one build, and then take those libraries and then integrate them just as third-party libraries into the rest of the app? Or you try and build the app and DPDK in one go? Or this is a general question, not just for you.
For us, it's kind of like DPDK pipeline, right? We start the build at the beginning, and at the end, everything pops out. Along the way, we build the libraries and link them into our application.
Okay.
So one of the things I was doing is I thought I tried to upstream this at one point, is to add to our current build system different file extensions. So you could actually build have a different set of make files for your environment that DPDK could at least execute. That was rejected, but I think we could definitely put a different set of make files alongside of the current one we have today if we want to support it, and then either deprecate the current one we have to go to the new one or whatever, but have some sort of transition model, I think. And I did that for the FreeBSD builds. This is like for building FreeBSD code, is I put a set of make files alongside of the FreeBSD make files that built using DPDK's build system. And that actually kind of worked kind of nice. There was a lot of editing and crap, but it worked out well. But
hi, I would say also that a slub equivalent to memory allocation is pretty much needed. I have built a DNS server on top of DPDK, and I had to use several pools and make some kind of layer on top of those pools, but that's a huge waste of memory. Another point is the support of namespaces for DPDK interfaces, particularly if you have OVS DPDK integration. if you want to have an interface in a specific namespace, then that's a big point missing.
I'm not sure I understand your point about namespaces. How are you splitting things up amongst namespaces, or could you expand a bit on the problem you see? Or
if you have multi-tenants and you have a special namespace where you have a number of VMs, and then what you want to have is the OVS can have interfaces in this particular namespace, and they cannot mess up with another set of namespace where you have also interfaces.
Okay, so this is nearly like security partitioning within a DPDK process again.
Right, which exists today in the kernel, but not in the user space level.
Okay. Interesting. Well, that's certainly not on our roadmaps anyway. Is there anything that people are planning to contribute to DPDK that you'd like to talk about? Or, sorry, Frank.
Different topic.
Sorry, just wait for the mic. It makes it easier for everybody to hear.
Yeah, I'm Frank Baudin. I'm from Red Hat. And I'd like to know the status about ATS and stable API.
So, where's Mohan? Does he want to do you want to say anything about that, or do you want me to try and talk to you? You probably know more about the stable release than I do, or John. I mean, we are working on one, but I'd just rather let the experts talk to that.
So I'm John McNamara, I'm an engineering manager at DPDK, ex-developer in DPDK. Yuanan is our maintainer for the LTS. So there's two questions: what's the status of the stable LTS release and the ABI? And I have a session tomorrow about usability, which I'll talk to, but briefly. So from the 1607 release, we have a stable release. We have a stable branch that Yuanan is maintaining. Several people are helping him, such as Christian Earhart from Canonical. Thomas is directing patches there. So basically fixes are going into that stable release. We have a kind of 1607.1 queued up for packaging in the next few days and getting it into tests. So we'll have a stable release package. After the 1611, when we accumulate more fixes, we'll probably have a .2, and then we'll move on to a 1611 stable release. So each release will have a new stable release. As well as that, and that's kind of targeting the people who say, maybe such as OVS, who might be stuck on a certain release, who say they may tie OVS 2.6, for example, to 1607. So, and then if some kind of critical feature comes out, critical fix comes out, but they can't wait for 1611, that doesn't work for them. So it allows, the stable releases allow us to backport fixes, so that if somebody is using 1611, but the duration of that is one release cycle, which is approximately 3 months. And as I said, that's the target people who just need to get fixes backported to a specific release. For the long-term support release, that should be 1611. So that will start in the same way as a stable release. We'll have backported fixes, but the duration of that is aimed as 2 years. So that's longer, and that's aimed at the open source vendors, the Red Hats or the Ubuntus. Whether that is what you want, you need to engage in that discussion and say, yeah, this is what we want. But the aim is that we keep it stable over well, it's basically a stable branch over 2 years. Allow backporting of fixes, possibly leave the door open for backporting of features if people have a case for that. If they're willing to do the work to backport it, then we won't stop it. I think it's important that for the stable releases and for the long-term support releases, that we make them usable for people who want to use them, so that we don't just say, hey, this is our vision for what it's going to be, and nothing deviates from that. I think we have to allow it to change and see how this works out. So I put up the RFC, a couple of versions of it, a couple of months ago, and as I said, from 1607, we're basically trying that. It's working out. There's a reasonable amount of work in it, but people are helping to identify fixes. Yuanan has a very good kind of system set up for identifying patches that are fixes. So that part is working out. There is maybe open issues about timing of these when we get them out, because a lot of the fixes don't come in till kind of say later on in the release cycle, so the stable release isn't kind of mature enough until late in this release cycle. But anyway, as I said, it's there to support a specific use case that we were asked to support, which was for people who were stuck on certain release. Okay. Yeah. Okay, so question from the floor about how this works with the driver aspect. So a lot of the pull mode drivers have big blobs of code that are in the kind of so-called base folders, and they're probably generally shared with kernel drivers or other in-house drivers that people have for the pull mode drivers. And that's kind of a thornier or trickier situation to support over a long-term release. Because a long-term release would envisage, smaller fixes and patches, whereas that base code often gets updated in quite a large way because, you have support for a new NIC or a new variant of a NIC you might have. So that's tricky, and I think we're going to have to kind of work out how that happens just by case basis. I think we should leave the door open for it. I mean, if somebody has, 5 variants of their NIC, and then there's a new one that comes out, but the LTS only has the device IDs for the first 5. We're not going to stop people, backporting that, and I don't think we should. Yeah, there's a question down here.
So then I feel we are back to one of the Bruce comments. How much of the code do you think we should remove from DPDK to simplify the LTS? Because when you do your LTS check, maybe you do it with an Intel CPU. What about IBM, Dalera, ARM CPUs? You do it maybe with some Intel NICs, but what about QLogic and other NICs? You say there is the issue of the base driver, which is quite complex. So I'm just wondering if LTS should be the whole code for the whole scope of DPDK, or should we state that LTS is just for a specific CPU, specific NIC, specific Linux distributions? And what should be the scope? And maybe from that scope, it will give some idea of the code that someday we will need to remove from DPDK.
Okay. Well, that's a good question, and these are the type of things we need to discuss. So, I mean, that's a good question for everybody in the room who's invested in this. Or, should we make LTS, more specific to what is the CPUs, NICs? Did you say OSs as well, or compiler versions? Definitely, from a maintainer of an LTS point of view, that would make life easier, right? If you had a very, a smaller subset. Opinions on the floor on that, especially from maybe people who are involved in long-term support.
Maybe just right now, what is the scope of LTS? I mean, on which target do you check, on which distributions, which NICs?
Yeah, so the RFC says that the LTS should be tested on 4 main OSs that would be also considered long-term support. So whatever Red Hat is closest to the release, whatever their LTS is, whatever the Ubuntu long-term release will be, which I guess is 1604 at the moment. Yeah. Same for FreeBSD. I guess FreeBSD 11, and in the RFC said SUSE as well. I think that SUSE are also around 11. I think anyway. So we should whenever 1611 comes out and we say this is going to be the LTS branch, we can say then these are the ones that we're going to support, which obviously will make the maintainer's life easier. But also because we need to limit the amount of testing that's done on this, because we have quite a long release testing cycle for any release. We have some people here from tests, and it takes about 3 weeks of maybe a dozen people working through a whole variety of OSs and compilers and NICs. And to do that for point releases would take a lot of work, so we do need to narrow the scope of what what we're going to support in LTS, so that we can reduce the scope of testing, so we can get releases out more quickly. So I think that is a proposal. I mean, that was in the RFC for the OSs. for the NICs, I guess whatever is supported at that stage.
I mean, our validation within Intel is only really covering the Intel NICs. We are relying on the NIC vendors and to validate their NICs, and the ARM vendors, to validate the ARM platform, and PowerPC to validate PowerPC, and so on. So it's not like we have one validation team for all of DPDK. I mean, this is a community effort in development, and it's also a community effort in validation. So we're going to take and validate stable release and LTS with Intel platform, or IA platform CPUs, and Intel NICs. But we literally don't have the equipment to test, these other NICs and these other our platform types, because we don't always have those in our labs. So I think it will have to be a community effort as well. Thanks, John. Was that a better explanation than I would have given?
Yeah. So in general, I think while it's correct that you say you don't want to cover the patches of all platforms and just a user set, that's not a single person or a single team's effort to validate.
Yeah.
But I think the rule for LTS should not be to totally exclude and forbid other platform fixes. So if the others care, and Power or ARM or any of them actually help backport provide fixes to be easy to maintain, support the testing, it's not a rule to not support, right? So your suggestion was just that the DPDK organizations or communities' purpose on serving the LTS would focus on the subset, right? So if the others care, provide all the patches, that would still be okay, because that is important. So if ever there's a rule to limit the scope, that rule should not be, it's not allowed, but it's not provided by some part of the project. I think it's important.
But then the question comes up then, if we get a fix, if there's a bug fix put into 1611 for a platform or a NIC type or an OS, and there's no commitment from anybody to actually validate that, do we backport that fix? The fix is there, but we don't have a validation commitment for the stable release and LTS release. So that's kind of becomes a grey area, I think, anyway. What would your opinion be on that? Probably backport, or would you say, well, no validation can't begin?
Okay. So, well, I mean, I'm not making the rules, but my suggestion would be that, as you said, the commitment has to be there. I had just the same case with power fixes to DPDK 1607 a few weeks ago, and I said I denied to support it so far until you support it. And oh, wonder why? 2 weeks later, we had a guy working all week on that stuff, and it worked. So it's just about stating what your demand is. You need the commitment to test and verify that, and they either care and do it, or they don't. So yeah, my suggestion would be the commitment to actually test, it has to be given. And on the other side, it's not only that if there is a fix for any, let's say, non-default platform, that they have to care for theirs. I mean, Intel will take care for their NICs and anybody else, because even if it shouldn't be like that, you can always break somebody else's code unintentionally.
Yeah.
But that's the part of the release verification anyway.
I think this is something to remember for later today, that this distributed aspect of CI loops is critical to have hardware supporting one particular release. And having a centralized CI loop in some foundation will not bring anything of value. And we need to be more distributed. So this discussion is very important, I think.
My name is Morten. I'm from Smart Shell Systems. We do bandwidth management appliances. We're porting our application from Linux-based loadable module thing to the data plane development kit.
Great.
We just started doing that, so we're not so experienced with the DPDK yet. One of the things we're seeing is data plane is built mainly for data plane processing. So the interface to the control plane is non-preemptible. And coming from a chip business before, where we were doing gigabit switches, there was a clear separation of the data plane in the chip and the control plane, where you configure the tables in the data plane. And in the DPDK, the control plane, the lower layer of the control plane controlling the tables has to be non-preemptible. And that's going back to the original discussion, or the previous discussion about separation, that you need the lowest layer of your control plane has to be non-preemptible, and that's a single point of failure. So we have to implement that in one process. You cannot have multiple control processes that are interfacing directly with the data plane development kit, table updates, for instance. So that would be nice if there was some possibility to have preemptible processes being able to manipulate the tables in the data plane development kit, the fast plane tables.
Okay.
That's one thing.
Walter, you can just wait for the mic there.
Right. So the question is, in the control plane, when you look at that, are you looking at it from the point of view of actually the kernel, or are you looking at the control plane basically moving up into user space? Because I think that's a key issue right now that we're on the cusp of trying to figure out.
Get actually move the mic closer.
Closer.
Make sure everybody hears.
No experience with this. No, I think that's a key decision right now. There's a lot of companies that are trying to decide, do we put the control plane up into user space and have it much closely affiliated with the DPDK to make those decisions quicker? Use the kernel purely for switching functionality, not really for its original control plane functionality.
We are moving completely away from the kernel. So everything will be user space and will be completely independent of the kernel. We used our current application is everything in the kernel, a lot of loadable modules, and we're getting rid of all that. And the kernel will only be there so we can run our whatever Lighty web server, whatever general stuff and booting up. It will be mainly be bootloader and user interface.
That's what I'm seeing more and more. That's why I was asking you that question. A lot of companies are going more to that model.
We have been, and that's another thing I want to address. The kernel has a bunch of hooks and a bunch of specific ways of, a packet runs through the kernel in a specific way with all the different filters and lots of hooks in different layers. And one thing I like about the data plane development kit is that it's very straight and simple, and the libraries that are added to the data plane development kit, the lookup libraries, for instance, are separate libraries that you can choose to use or not. And there was a discussion about the packet capture feature that started introducing hooks directly in the drivers with callbacks because it would be easier to capture the packets with a callback in the drivers. And I don't think they belong there. It's an example. It's very important for DPDK to keep the libraries optional. And when you do add libraries on top, which I would like to see a lot more libraries, that would be nice, make sure that you don't add more stuff to the lowest layer, because then you will end up having a clone of the kernel with lots of hooks and complexity that you don't need if you don't use it. And the packet capture callback thing was introduced because it was nice to have there, but it might just as well belong in the application. When you extract the packets, you could call the capture feature whatever, capture library, and as I said, it's an example, but you're adding stuff to a lower layer to support some support library that if you don't use that support library, you still have to consider what's this and what's that, and if you add more and more hooks and changes to the mbuff structure to support higher layer level libraries, then you have to consider when you're looking at even just the lowest layer, what's this, what's that, do I need to initialize this, and so on.
Okay, that's really good feedback.
Yeah, so
I'd love to have a discussion with you later, actually, on a lot of your input.
Yes, but to answer to this one, I guess And to help the LTS as well, it would be good to separate clearly in DPDK what is the core and what is example. And I would put the LTS on the core. And what is the core, from my perspective, is just a minimum of library and to make the PMD run. Because the hash table, the TCP dump, everything, and potentially even the host user. This is something that can be implemented in another way. And if you take the VPP example, which is the first open source stack with a lot of first, second, but at least it seems to work, this one. I mean, why? So you see what is the VPP core, the DPDK core, and DPDK could focus on the driver. Then you have example, and then people are free to create their own stack, but there is a misunderstanding. DPDK is not a stack, it's written. You know, on the one of the first page of the website, what is DPDK? But people, they still use the NPM, the IP pipeline, but at the end, people, what do they do with DPDK? They just use a PMD driver, and they build their stack on top of it. They can sometimes include the hash table, but do you have statistics, for instance, about the example flying on real product? How many products embed the hash table? How many products embed the IP pipeline, etc.? So we know what is core, what is not core. Make sense?
Yes. Yeah. Anybody want to make another comment on that? Thomas?
Yeah, I would like to continue the discussion of the scope because it was something you were suggesting in your slides. Maybe do you want to talk more about it now?
Yeah, by all means.
Okay, so maybe I have few slides to better explain the situation. Is it possible to print the slide, please?
Excellent. I hope this isn't running into your talk for later.
Excuse me. You want to talk the scope, and I promised I will jump in the topic.
Yeah, no problem.
So, I think everybody agrees the core of DPDK is mainly the EL for the CPU support, some kernel modules to make it working, the drivers API, some core libraries to manage the mbuf mainly, and few of libraries on the right. Not sure it's part of the core, but some of them are really useful, especially KV-args. It's used in some API. Then we have some libraries which are not useful for the drivers API. But some applications use it. So we have the algorithm libraries. Some of them are managing some packets, moving the packets, modifying the packets. So that's some helpers to build a stack. We have two libraries for debugging and statistics. And at the end, the packet framework, which is a layer on top of the drivers API. That's clearly another layer. And just to finish the overview, then we have the application and examples. Especially, I would like to talk about the examples because we have. I think there was an agreement that examples are really useful inside the DPDK repository to prove that things works and to show how it works. So it complements the documentation and it complements the testing. But, so there are some examples which do that, which show how DPDK libraries work. That's the star in the slide. And then we have other examples. Some of them act as staging, because we don't know if we have to integrate it in DPDK. So it's staying there. And we have some examples which are just there to show what can be done on top of DPDK. I repeat, on top of DPDK. So we can really ask the question, should we keep these examples in the DPDK repository? Now, why is it a question? Because a few things. First, when you have to modify something in a DPDK API or in a DPDK library, you have to make sure that everything in the repository is still working. So when you change something in an API, you have to fix all these examples to make it work. And probably you don't know how it works. Maybe you don't even know this example is in the repository. So it's really a blocker to make some deep change inside the APIs. And more things, I think it's confusing to understand what exactly is DPDK, what should we test in DPDK, and is it mandatory to use, these libraries to use DPDK? Actually, like Frank was saying, no, it's not mandatory to use the DPDK, don't say LPM, to use the DPDK drivers. Examples are maybe VPP or other applications. So that's a question, that's confusing, and I think the scope of DPDK is still an open question, and if we can make progress on it this week, I think it would be welcome. Your comment maybe, Bruce?
Yeah, thanks for that, Thomas. It's great. The scope of DPDK is kind of open because I agree with you that the POMO drivers are really the core part of DPDK that I think just about everybody uses when they use DPDK. It's really for the POMO drivers. But I also think there's some good value to be got by the higher level ones. The extra libraries, the ACL libraries, the hash libraries, the LPM, because my opinion on it is, yeah, there's some people who are going to take the POMO drivers and then have their entire application on top. But if somebody's trying to write a new application from scratch, do we really want to have them get the raw packets in and then do everything else on top of that from scratch? So I think there is value in having DPDK being more than just a bag of drivers. Now, your point about the examples is another interesting one. I know from experience as well that you're going to make a change, you potentially have a whole bunch of extra applications to go and change. So that's the downside to it. The positive side, though, is it helps you to experience what people who have actually got applications built on DPDK are going to have to go through as well. I expect in many companies, especially the bigger ones, people who work in the code are not always the people who originally wrote it. So they're going to have to go through the exact same exercise of having to take something that was written on DPDK X and port it to work on DPDK Y and change all the APIs without actually knowing what the original intent of the author was. So I think it's good in the way that it can also act as a sanity check to make sure that you are aware of what you're going to put through your users through as well. Now, I'm not saying that we need necessarily all the applications that we have, but I also think they have value. And it was something actually I wanted to ask as well, is what kind of examples do people think we need in DPDK? Is it good just to have the simple applications that show how feature X works, or do we need more applications that are slightly more complicated? You know, that show pulling in packets, that show packets interacting with the control plane. You know, because that's not something we've ever looked at really in DPDK, or very little looked at. We have made some attempts with things like KNI, is how do you interface the control plane and the user plane? And I know something other people have brought up to us before. So, sorry, that's just my initial 2 cents. I don't want to try and have this as a talk by me. I'm trying to keep it as an open discussion. So, has Sarma answered another question here as well? Yeah, sorry.
Just a follow-up to the discussion of the roadmap. My name is Evgen Zhoybekov. I am from State Technical Service in Kazakhstan. We develop DPDK applications for our private government networks. I'd like to speak about a little time ago. We were choosing different approaches on developing data processing, packet processing applications. We've seen the network processors, we've seen DPDK, and DPDK was chosen because of the good trade-off between functionality and performance. Regarding your question about is the performance is the key for DPDK, I think it is, yes, it is the key approach, because my personal fear about DPDK, it becomes bloated in the future, because if you add more features, add more different approaches, for example, in mailing list, a little time ago was a set of patches for event-based approach, for example, and we are aware, we're afraid about the performance issues. Of course, there is a problem, another problem about the DPDK. It will require to develop some sort of management layer on top of DPDK, because for controlling the application, we needed to carefully read every function that we run on each L core, and we needed some layer to rewire all these functions and all these cores and all these queues and ports, and this management layer was a bit of messy for us. And event-based approach may be, for example, maybe convenient in some cases, but the original approach is far more good, far better in terms of performance. Which is just the remarks.
Okay, thank you.
Thank you.
Sorry, well, look, Vince has hand up a while back as well. Are you still? Yeah.
I feel bad because I will come back to Preemptive, but I do agree performance is a must, at least for 6-win. It's really a must. And then of course there are some other layers which are needed. Regarding the libraries, like you say, Ash and others, and what I don't understand, because I know it's from some holidays, why is it in DPDK and not in some glibc optimization? Is it because some people in DPDK doesn't like GPL, but they prefer BSD license? Could be a reasons. Because at the end of the game, some of the tools which are in DPDK are really things that should be optimized in the libc, in the libgcc and others. So, and I think there's some confusions, and that's why some of the like Ash optimizement copies and others have nothing to do in fact in DPDK as of today.
Yeah.
But of course it may not end up as a BSD license at the end of the game if we change it.
Yeah. Thanks. And I would agree with you on some of those points, but not necessarily all of them. Things that functions that are already in glibc and the way of copies of in DPDK, and yeah, I would tend to agree there. But other ones, the licensing, I'm sure, is one of the concerns. Other times, maybe we want to keep things, specific to packet processing, because that's one of the differences between kernel and kernel drivers and DPDK drivers. DPDK is all about performance and packet processing. Kernel often has to be quite generic. Sorry, again, I'm starting to talk, and I want to let others talk. Jane. Oh, sorry, Jared, was you next?
Hello. Yeah. So regarding event model discussion, so what we thought is make event model as a separate items. It's not directly coupled with the PMD driver. So it's yet another library form. It's an optional thing. It's not directly coupled with the PMD driver. So it's basically follows the DPDK philosophy as a library.
Yeah, I think that's something that I think multiple speakers have agreed on, the fact that we need to keep things optional so that we're not pushing down into the lowest layers all this functionality, and we've got an a la carte menu of different bits that you can pull and use. Wasn't that one of your main points as well? So, sorry, Jing.
So I'm Jing from China, so I was a DPDK engineering manager. Probably I'm not visible in the mailing list. But I probably see something slightly different. It's like the DPDK usability, right? So if you want to make DPDK more usable, so you need adding more stuff there. So I know like different people have different opinion, but I mean like this all kinds of like business in the background to make this kind of decision, right? So my question on the roadmap might be like, do we want to adding more like DPDK plugin for the other open source project, which make DPDK like it's an underlying library, but you have more sample plugin, which allow the entire industry make more easy to consume other open source. Is this something we could consider in the roadmap? Maybe different Git repo or whatever. So.
Thanks. So, Unix is about having small things doing what they have to do the best way. My idea is not to kill all of the library or whatever, is to extract them from the core, to distinguish what is the core, what is not the core, and then you can have a project on its own, and then when you build an application, you will pick up your DPDK, You will pick up your hash library, you will pick up your event, whatever, and then you build your stuff. So some project like VPPs, they come with everything but DPDK together, but you can think of others. So my goal is more to split the big DPDK, because DPDK is very big, in order to see where you want to put your firepower, and what is really the core of DPDK, and what is then missing for the use of DPDK. But you can build, you know, multiple components to make a solution, but not to have a big fat component with a lot of inertia. Each component can have its own roadmap when it's independent. So you gain agility.
I could add that DPDK is already split this way, because there are numerous projects using DPDK and adding more layers. We just have some of these higher layers inside the DPDK Git repository. But okay, it's hosted on dpdk.org because that's their place. We want to see them there. But why in the same Git repository that sends the driver? That's a simple question.
So you're suggesting that you'd have 2 repositories, one for the drivers and the rest for the rest of the data plane libraries?
2, 3, 4, as many you want.
Okay. My view on this, personally, is that it's a data plane development kit. It's not just a library, set of libraries, or a set of drivers, bag of drivers, and not much else on top of it. I'd like to see it all as one kit. Sorry, Declan, Walt, and then Declan.
Just on that point, I think there's a big danger if you pull that into separate Git repositories that things will fragment. It becomes much more difficult for a user coming in. So are you pointing to 4 different Git repositories? I think it might make sense to logically split things a little bit more clearly within DPDK's current repository structure. Make it clear this is the core functionality. Make it clear that these are some helper libraries, but have them, if they don't become in the same library, you get versioning problems that people also tend to go to a different Git repository, which is this built against. That could become very fragmented very quickly. I think it makes sense. These even though they're higher level libraries like the hash library and stuff, they're all based fundamentally on using the mbuf as the structure of passing data around. They're based on the metadata and structure of the metadata in there. And if you put those out into other repositories, I think that becomes a much more difficult for the end user to deal with. That's just the point.
Okay, just a simple question. Excuse me. Is VPP, is OVS using mbuf? Are they implementing the same kind of libraries like in the DPDK repository? Yes. That's exactly the same thing. And OVS and VPP are not in the DPDK repository, right? That's the same thing.
Right, but just because 2 people implement the same kind of library doesn't mean it doesn't belong to DPDK. If somebody else were to write another pull mode driver for a piece of hardware, we already have a pull mode driver in DPDK, would that be a reason to take that driver out of DPDK? That's kind of the counterpoint to that argument that, yeah, well, this group here is also implementing that functionality. So I want to let Walt get a look in. It's very unusual to see Walt having to struggle to get a word in, but
thanks.
Refreshing to see sometimes.
So I guess I wanted to come back to your point here. The DPDK, yes, it started off in a certain manner, had a certain concept behind it, and it has evolved. One of the big pieces, though, I think, is that people don't necessarily look at is it is evolving into supporting a lot of different concepts. And as such, those elements that are at the lowest level, and this is a tricky issue, have to supply a lot of information to those higher ingredients to determine what to do. Now, at the same time, you need the very fastest possible pull mode drivers to get the fastest throughput. But in other scenarios, other types of systems, orchestration layers that require that massive amount of information, you somehow have to supply it. So you have to come up with a mechanism that you can accomplish both. And there's various ways to do that. So yes, we want to keep all the goodness, the speed, etc. But I think you have to look at this as the DPDK is used in an environment that's just a pure router. It's used in an environment that's got a much higher end application that's got to look at some of the data elements and the performance metrics to make decisions at a high level. You can't make those decisions down the DPDK without knowing that knowledge. And so there's a lot of different, there's a bunch of different trade-offs, and you should be able to create the DPDK in a manner to accomplish each one of those goals. But if you say, no, it is only this, that's a problem. No, I just want to kind of take your point on a little farther. And I think it's an important aspect that you have to look at the DPDK is evolving, and you need those types of pieces of information, but in other cases you don't. So it has to be flexible.
Yeah. I cut off where I was going to talk down there.
Yeah, I think it's interesting that both packaging and scope are being talked about at the same time. It would be by no means exceptional for any open source project to decide what is core functionality and have that left as default at build time, and then decide what is optional functionality and have that as being something that you can additionally enable. I don't see any reason why when you type make, it needs to make everything, and there can't be some things that you can optionally make later. And when I'm thinking about a good example, I think is systemd, which is a fairly enormous open source project, but really most distros who use systemd only use small parts of system, enable some default options during packaging time. So, you know, I think we can deal with the scope question by deciding what's on by default, but not necessarily fragmenting by putting things in different repository.
Okay, thank you. We've just got a couple minutes left. No, go ahead.
Yeah, my name is Rabi, I work for Intel. I'd like to emphasize the point made here about the open source and the hooks to open source. Now, to make DPDK, I believe, more usable within the industry, maybe it's worth considering other use cases in NFV. And since DPDK started supporting devices and has already Ethernet and crypto, it might be worth considering how do I report this information to orchestration solution, for example, to allow it to make a decision based on this information to decide to deploy a particular NFV or VNF in the platform that will run DPDK on top of it. At the moment, there's no mechanism to have that enabled.
Okay, maybe enough time for two more comments. There, down the back. So you go next.
I have two comments. One is about the packaging. So we're doing a shrink-wrapped appliance, and we're compiling everything from scratch. So we don't really so much care about the defaults. We'll modify this compile time things we need. And so I guess there are two types of distributions. There's shrink-wrapped, that appliances like we do, where we compile everything, set up the options. And the other is the generic library that are distributed with Red Hat and so on for general applications. And they could just enable everything and you can use whatever you like, because then it's already there in the library, you don't need to recompile it. So that's one comment, two types of distributions. The other comment is about the examples, how to use, what's the purpose of the examples. And I see Data Plane Development Kit as a library and not so much as a framework. However, the optimal way of using it is some of the libraries, for instance, the reassembly library and the Quick Assist and so on. There are some thoughts about what's the way this is supposed to be used. And I think the the examples should reflect that. And they should be examples showing what's the intended use of this and how do you do it in the detail. And if some of the libraries overlap or you have to do something in a specific order, then it makes sense having examples showing collect the packets in this order and then process them in this order afterwards. That's the main purpose of the examples. Yeah. It's kind of the source code.
So you think the simple examples are good, just showing the one thing in isolation, this is how you use it?
Yes, and if you need to do something in a specific order, when you combine some of the libraries, have an example showing do this and then this.
Okay, for particular pairs of libraries.
It's detailed documentation because the general documentation is never perfect.
Okay, thank you. I think last comment, and then I'll wrap up.
We are really here for data plane development kit. We're not here for NIC or interface development kit. We're not just about PMDs. It's about how to make data planes faster, which includes script-through drivers and whatever other drivers. Rabi here, he says he's from Intel, but he's from Altera. So how do the data plane really leverage reconfigurable hardware? If you just consider the reconfigurable, the FPGA as a NIC, then you're missing a lot of the value of the FPGA. And DPDK, I think, is covering how FPGAs are included in the picture, and it might require a whole new set of APIs to actually properly handle that. And I think that's really the core scope of DPDK, not just the NICs.
Okay, thank you. We're pretty much out of time, but since I've been put on the spot to lead this discussion, I get to have the last word. So thank you very much all for this discussion. This is quite interesting, and by all means, please feel free to come up and introduce yourself to me later on and continue on some of these discussions. I'll be fascinated to hear different viewpoints from different people on this. My own opinion on it is, I've already said it's kind of clear, I'd like to see us as being a full data plane development kit, as you said, not just for NICs. And the other point on that though was whenever earlier this year when Mike Glynn, who's over there, did the user survey and sent out the survey for DPDK, I was helping go through some of the results, especially the freeform text and things like that, and going through it. And one of the things that struck me was there's how many people using that. You know, it was like, I didn't know anybody was using that, but it turns out that quite a lot of our other components, other than NICs, are quite widely used by people we don't often see on the mailing list. So that was one of the things that kind of struck me out from that survey. So I'll leave it at that before Tim pushes me off stage. So thank you very much for all your contributions here. Made my life easier. Thank you.